This video will take you through how to measure the rate of transpiration of a plant using a potometer. Before we start, this is essentially what you're aiming for, but the most important piece of this apparatus is to make sure it's airtight with no air bubbles in it, and that's also the most difficult part of the setup. The first thing you want to do is take a glass pipette and submerge it in a tray full of water. If you tip it slightly, you'll notice that all of the air bubbles come out of the pipette. If they do not, you can gently use a plastic pipette to suck the remaining air bubbles out of that pipette. You want to ensure that no air bubbles remain. Once you have done that, you want to repeat the process with the plastic tubing, again tipping it to remove the air bubbles and, if necessary, using a plastic pipette to remove the remaining air bubbles. Now, whilst this process is tricky, you want to make sure that you really spend the time making sure that you get the air bubbles out of the glass pipette and the plastic tubing. If any air bubbles remain in either of those, then the potometer will not work properly. Now, in the spirit of keeping air bubbles out of your potometer, the next piece has to be done very quickly. You need to cut the stem underwater. Now, ideally, the whole plant would be underwater, but clearly if you have a pot plant with soil, that's difficult. So just do it as quickly as possible to avoid any air entering into the xylem of the plant. Once you've done this, you can take the stem that's attached to the leaf and insert it into the plastic tubing, take the plastic tubing and attach it to the glass pipette. Of course, all of this still needs to be done underwater to continue to avoid air bubbles from entering your potometer. It is often recommended also to use Vaseline at the points of connection in order to ensure an airtight seal. Again, continue to do all of this underwater until you can be as sure as possible that your seals are airtight. The aim is not to have any air bubbles in the apparatus, and this will allow for the greatest chance of having a successful working potometer. If you have any parafilm available, this can also be extremely useful in helping to secure those seals. Once everything is as airtight as you possibly can make it, remove the potometer and gently attach it to a clamp and stand as shown here. At this point, you might notice some air bubbles in your potometer. If that's the case, it may be that you might need to start from the beginning and remove the air bubbles again. To measure the rate of transpiration, first mark where the water level is on the glass pipette. In other words, where the air has gone into at the end of the glass pipette. During transpiration, water evaporates from the leaf. As a result, water is taken up by the plant and the air moves into the glass pipette from the open end. To measure the rate of transpiration, you'll need to measure the distance that that air bubble moves into the glass pipette in a given time. The greater the distance moved by this air bubble in a given time, the higher the transpiration rate. It is possible to use this potometer to look at the effects of different independent variables. For example, a fan could be used to simulate wind, the different speeds of the fan to simulate different wind speeds. You should compare this against a control where there is no air blowing or still air, represented by turning the fan off. You should also be mindful of controlling other variables. I have seen students before put a bag over a leaf in order to simulate still air, but be aware that this would alter the humidity surrounding the leaf. So, as a review, the potometer works because water evaporates from the leaves during transpiration, and therefore the air bubble will move into or along the pipette as the water is taken up into the plant to replace that lost through evaporation. In order to measure the rate of transpiration, measure the distance or the volume into the pipette moved by the air bubble in a given period of time. Make sure that you repeat your measurements and control for other variables. For example, when you repeat it, keep it at the same temperature. Then once you've measured the distance or the volume in a given period of time, you can calculate rate by doing distance or volume divided by time. The units, therefore, might be, for example, millilitres per minute or centimetres per minute. A word of caution. Measuring the rate of transpiration using a pedometer is an indirect measurement, and this is because it measures water uptake as opposed to the water evaporating from the leaves. Be aware that water that is taken up by the plant can also be used for other processes, for example photosynthesis, so the actual transpiration rate may be lower than that indicated by the pedometer.